Okay, so we're going to do some division practice here, and we want to find some decimal answers here. So I found a problem here that should help us work on this. So solve the following without using a calculator, giving our answers in decimal form. And the first problem we're going to work on is 16 divided by 3. Then we're going to work on 3 divided by 16. Okay, and then we've got similar things for problem 2 and problem 3. Let's then start by laying this out in the most sensible way that we can. If we're going to go for a decimal answer instead of a fraction, things are trickier and we're going to have to use, I think, the bus stop method. So I'll show you what I mean. So we've got 16 as our dividend and our divisor is 3. So we lay it out like this. But what I've done is extended the bar because what I'm going to do is just make 16 into a longer figure by adding zeros. So obviously not changing the value, but turning this into 16.000. Alright, now we're going to have some fun with division. It's a very good way of practicing our times tables and making sure we understand how to get to the correct quotient if that's what we're going to work on here. Alright, let's just give it a go and see what happens. So 16 divided by 3, well, that's going to be 5 because I know that 3 times 5 is 15, that's nearly 16, and I know that 3 times 6 is 18, so that's going to be too much. So 3 times 5 is 15, and we write that underneath using the long division method. Okay, so now we subtract because we need to know the remainder, and the remainder is in fact 1. And I'm just going to pause here to draw a line here going down from the decimal point. And I think what this will do, I'll just draw a dotted line in fact in another colour. This will just show us, there we go, what we're doing, and it will help us to see the importance of lining things up when we're using this method. Okay. Alright, so once we've done that step, we know we've got a remainder of 1, we start the problem again. In other words, we divide 1 by 3. So 1 divided by 3. Now normally we'd say a third, and then we'd stop there. The answer is 5 1/3. But what they've asked us is to give the answer in decimal form. So we're going to generate a decimal here using this long division method. Okay, so 1 is too small to divide into, but if I put the 0 next to it and think of this as actually 10 tenths, then I've got 10 tenths divided by 3. And if I put my answer in the 10th column, then it will be just the same as dividing by 10 divided by 3, but putting it in the 10th column makes it 10 times smaller. Alright, let's just use the method now and see where it gets us. So 10 divided by 3 gives us 3 in the 10th column, in other words 3 tenths, and we multiply out and write the answer underneath to get 9. In fact 9 tenths. Okay? So now our 9 tenths from our 10 tenths, so subtract 10 from 9, giving us 1/10, so a remainder of 1/10. Okay, so now we're going to think about dividing again. Now we already know that 3 into 1 gives us this 3 answer. So if we bring our 0 down, we add a 0 here, we go 3 into 10 again, that gives us 3, okay, which we write up here. 3 times 3 is 9, and our 9 again has to very carefully go below the 10 in that 100th column there. Okay. Now we subtract the 900th from the 10 tenths here. We just think of it as 10 subtract 9. Let's put our subtract sign in there. And so we've got 10. 9 from 10 gives us 1 remainder again. Okay. So now we're dividing the 3 into 100th. Same pattern. We think of it as, in fact, 10 thousandths. 10 divided by 3 gives us 3. 3 times 3 gives us 9 in the the thousandth column now. So it does get rather confusing as we go down into the decimal. But I think you can see what's going on. If we subtract 9, then we've got a thousandth left over. Now we could go on doing this clearly forever. And that's what's really interesting about the pattern that we've arrived at. So we can actually stop, because we know at the top here, for example, it's just going to be another 3, isn't it? And we're going to have 3, 3, 3, 3, 3. In other words, dot, 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 going on forever. So we've actually got our answer. Our decimal is 5.33333, and so on, going on forever. And we can rewrite that 5.3 recurring. So the symbol, the dot above the 3, tells us that that 3 goes on forever. Okay, well, you might want to rewind the video if you're not sure about that and just go through that explanation again. You might want to try similar things yourself. Practice until you get that right, until you're comfortable with this method, and then move on to the next part where we get a little bit more complicated. Okay, so now we're going to do 3 into 16, or 16 divided by 3. So 16 is now our divisor, and the dividend is 3. And again, I'm going to extend that line, write my 3 down, and add 0. I'm going to add 4 zeros this time, because I can see that this is going to get quite involved. Okay, so as long as we follow this method, it should be fairly straightforward. We should get our answer. We should find out what the decimal form of this is. All right, so 3 divided by 16 is 0. So we put a 0 here, and we put our decimal point here. Now remember, as we're going down, I'm not going to explain any more what's going on, but we're going into the tenths, hundredths, thousandths to get our decimals up here. But we just think of these as dividing into digits, as if we're in the tens and hundreds, as if we're the other side of the decimal point. So let's give that a go. All right. So we've got 0 times 16 is probably a good way to think about it. So 0 times 16 is 0 here, and we subtract 0 from 30, giving us 30 again. Okay, so now we've got 16 into 30. So 16 into 30, well, only 1 16 will get us below 30 or below. So if we had 2 16s, obviously it would be 32. So it's going to be just 1 up here. So 1 times 16 gives us 16. And subtract the 16 from the 30 gives us 14 now. Okay, it's actually, of course, 1.4, but we just think of it as 14 at this stage. All right, 14 divided by 16 is the next thing that we've got to do. And what we've got to remember is that we're actually going to do 140 divided by 16. So always remember to bring down that 0 so that we've got a large number here that we're going to try and find. Because what we're asking is what times 16 gives us 140 or less? Well, 5 times 16 would give us 5 times, let's write it down, 5 times 16 would give us 80. We know that 10 times 16 would give us 160, so that's too much. So it's going to be something like 8. Let's try 8 times 16 then. Okay. Well, 8 times 16 is fairly easy to calculate mentally. If we did 2 times 16, that would be 32, so 4 times 16 is going to be 64, and 8 times 16 is going to be 128. If you're not confident, though, about that mental method, don't forget, written work, especially in tests and exams, is much better. If you can't do it in your head very easily, then you ought to write it down and work it out on paper. But I'm pretty confident that 8 times 16 is 128. I also need to check that it's not 9 times 16, and I can see that if I add 16 to 128, that's going to give 144, so 9 times 16 must be 144. Again, check this if you're not confident about these kind of high multiplications. But 144 is too much, so it is 8 times 16, and so I can confidently write my 8 at the top. Okay? So, multiplying out. 8 times 16, 128. And the next level. 128 from 140 gives me 12. Add my 0 here, and what I've got is 120 divided by 16. Now I can see that that's 7, because 8 times 16 was 128, and if I subtract 16 from that, what have I got? I've got 112. Okay, so 7 times 16 is going to be 112. And is that correct? Let me just do a mental check here. If I add 16 to 112, yeah, that's going to be 128. So I just paused to do that because mental checking, of course, we know is extremely important. We need to be really confident that the numbers here are absolutely correct. And if we're in an exam and we're stressed, it's very easy for even the best of us to make a mistake. So 16 added onto here gives me 128. So I know that 7 times 16 is 112. 112 is the right figure then. So 7 up here. 7 times 16, 112. Of course, just to remind ourselves, this isn't 112 at all. If we drew this line down here, we can see that this is actually 0.112. So it's a tenth, a hundredth, and 2,000th. But this method is a really good one for just keeping things much simpler than that, not worrying too much. As long as we're following the method, we're going to get the correct answer. Okay, so now we've got 112 divided by 6. No, sorry, we haven't. We've got to subtract first. Easy to make a mistake here. So we need to be really careful, follow the method, not work too fast. So 120 divided by 112 is going to be 8. And now we've got something that's looking a little bit more familiar with. We might be more familiar with this. So we've got 80 divided by 16, and that's going to be 5. 5 times 16, same as 10 times 16 divided by 2. So we know 10 times 16 is 160, divided by 2, 80. So 5 times 16 is 80. And we had that up there, in fact. So 5 16s are 80. We just complete this by putting the 80 underneath, subtract, and we've got no remainder. So we know that this is the right answer. Okay? So 3 divided by 16 is 0.1875. 16 divided by 3 is 5 1/3, or in decimal form, 5.3, recurring. Okay, problem 2 then. 19 divided by 5. So if we write down, again in the same format, if we write down 5 is our divisor and our dividend is 19, and let's just extend that a little, and we put a couple of zeros here. Alright, so what we're going to do is divide 5 into 19 straight away. So 19 divided by 5, well, 3 times 5 is 15, 4 times 5 is 20, so we're going to have 3 to start with. 3 times 5 gives us 15. And if we subtract this, then 19 subtract 15 gives us 4, and we bring down our 0. So we're dividing into 4, but in fact, let's just put our dotted lines here so you can see what's going on. In fact, what we've got is, we're going to think of it as 40. In other words, it's 40 tenths. Okay? 40 tenths, or 40, divided by 5 is 8. So if we put our decimal point here, keep everything in line, put our 8 at the top, we multiply our 5 times our 8, gives us 40 again, and so we've got no remainder. So the answer to 19 divided by 5 is 3.8. Nice and straightforward. Now, I suspect that the next one isn't going to be so straightforward, so I'm going to give myself plenty of room here. Well, in fact, maybe that's squashing it up a little much. Let's just erase that. Move that along a little bit more. Okay, so we'll put our 5 here, and we'll put 0.0000. See if 4 zeros is enough. Okay, and our 19 divisor here, and here's our bus stop. All right. So 19 into 5 is 0, and so 0 times 19, we're going to get a 0 here. We're going to subtract to get our 50 figure here. Okay, so our next level is 50. So we're straight into the tenths here, and we've got 50 tenths. So 50 divided by 19, well, 2 times 19 is going to give us 38. So we'll have 12 as our next level. We bring down the 0. So we've got 120. Of course, it's not 120. But anyway, let's divide 120 by 19. Well, that's a little tricky. It's obviously going to be a high number. Over to one side here, let's think of 19 times 10 is 190. So it's going to be between 19 times 10 and 19 times 5. So that's going to be 95. Let's try 6 times 19. 19 times 6. So, well, that's going to be 1 more 19 than 5 times 19. So if we add a 19 onto here, it's like adding a 20 on, subtracting 1. So we've got 115, 114. Okay? So 19 times 6 is 114. And that's going to get us where we want. So 6 is the figure that we put up here. 6 times 19, 114. Okay, now just pause the video if I jumped ahead a little bit there. Make sure you understand how it is I got this 6 times 19 figure, and before you move on, and then we subtract the 114 from the 120, giving us 6. Okay, let's see. So bring down our 0 here. We've got 60 divided by 19 now. So, well, 60 divided by 20 is 3, so it's going to be 3 times 19. Okay, and 19 times 3 is going to give us 60 subtract 3, so 57. So again, pause the video if you're not sure how I got that result. 57 from 60 is 3. So we now bring down the 0, we've got 30. 19 into 30, 30 divided by 19, simply going to go in once. And 1 times 19 is going to give us 19. So subtract 9, and we're going to get 11 here. So the next thing that we would divide into is 110. But I'm just going to pause there, because when we've got up to 4 decimal points, 4 below the decimal point, so we're into the tenths, hundredths, thousands, 10,000s here. If I kept going, obviously this decimal is going to get rather large. We don't know whether it's going to be a recurring decimal. It might be that it starts there and ends down here somewhere. But what we do know is it's larger. It's going to get larger and larger. So I'm just going to put dot, dot, dot. And that's our answer. Our answer to 5 divided by 19 is 0.2631 dot, dot, dot. Not necessarily going on forever. But if we go any further, we're going to get into too much detail. So what we can say here is 5 divided by 19 equals, let's just write it down here, 5 divided by 19 equals 0.263 to 3 decimal places. Okay, so 5 divided by 19 is 0.263 to 3 decimal places of accuracy, and that's because we got this 1 here, and the 1 is much smaller than 5, and so we know we're not going to round this up. We just keep it as 263, and so that's our answer to 3 decimal places, or we could say to 3 significant figures, and SF or DP is a good abbreviation for that. Okay, so now that we've answered that one, let's move on to problem 3. Okay, so 7 divided by 18. So if we write, so we've got to be careful here because the pattern before was that they had the fraction second. This time it's 7 divided by 18. So we've got 7 as our dividend and our divisor is 18. Okay, so we're going to put plenty of zeros here, I think, because as we've seen before, these can get rather involved. All right, we're clear where our decimal point is. We're ready to give this a go. So we've got 18 into 7, first of all, will give us 0. So 0 times 18 is 0. And then if we subtract that from that, we've still got our 70 here. Okay? So now we've got the challenge of 70 tenths divided by 18. All right, no problem. We've got to think about chunking again. We're going to write our 18 times table this time. So what are we going to get? 5 times 18 to start with. Well, 5 times 18 is going to be 90, so that's too much. 2 times 18 is 38. 3 times 18, let's try that. 3 times 18. Well, 18 add 18 is 36. Add another 18. We could do that, add 20. So we got 36, add 20 is 56. Subtract 2, we're going to get 54. So 3 times 18 equals 54. And you might want to just do a mental check here. Make sure you did calculate this correctly. One way of doing it is to think, well, 3 times 18 is the same as 6 times 9. And if we know a 9 times table, we know that 6 times 9 is 54. And also we would expect the digital sum to be 9. So 5 add 4 is 9. Okay, so we're happy with these figures, so we can happily then say 3 times 18 is 54. So we'll write our 3 there, and 54 subtracted from 70 is going to give us 16. Okay, so now we're into the hundredth. And we've got a slightly trickier problem here. We've got 160 divided by 18. Okay, so 160 divided by 18. Now we're going to have to chunk up quite a bit here. We're not going to go to 10 times 18, but maybe we want to think about 8 times 18. It's going to be in that sort of region, isn't it? So how are we going to do that? Well, 2 times 18 is 36. So double that, 72. And double 72 gives us 144. Okay. Now there are several other ways of doing that. Another way of doing it would be, again, this 9 times. 9 times 16, which I think we had in a previous problem. If we're in the 9 times table, we know the digital sum will give us 9, and 1, 4, 4 gives us 9, so we can be confident with that figure. Okay, so 144 is 8 times 18. 9 times 18 will go a little higher. So if we add 18 onto here, it's like adding 20 onto here, subtracting 2. So we would have 164, subtract 2, 162. It's gone too high. So we can be confident that it is 8. We put our 8 down here. 8 times 18 then is 144. Subtract 144 from 160 gives us, what does that give us? 16. Okay? And now we've got something interesting going on. We've got 160 here, just as we had before. We know it's 8 times 18. We know we're going to write 144 down here, and subtract, we're going to get that 16 again. Okay, so 16 again. Bring down the 0, and it's going to go on and on. So let's write another 8 there just to complete this. 8 times 18, 144. Subtract that, and we're going to get our 16 again. And so on and so on and so on. So what we can say then, so this is a really interesting example, is we've got an example here of a recurring number again, but this time it's not the first number that's recurring, it's the second number. Can you see that? So we've got the 8 is going to go on forever. In other words, we've got 7 divided by 18 is going to be, let's write it down here, 7 divided by 18 equals 0.38 recurring. Okay? Right, all that remains is 18 divided by 7. Now let's see what's going to go on there. Okay, let's erase these. So, pause the video if you want to give that a go yourself. You should have had plenty of practice here, and hopefully you enjoy challenges like this. They are pretty difficult, but you know, this is what we need to do. We need to develop our fluency, practice these kind of things so that we can become better and better with number. Okay, so some good practice here, and now we've got 18 divided by 7. So let's see if we can fit it in here. 7 into 18. And this may be straightforward, but it may go on for a long time, so let's give ourselves plenty of zeros. Alright, so we're going to be thinking about our 7 times table here, so that's going to be useful practice of that, and we're going into 18. So 7 into 18 to start with, 18 divided by 7 is going to be 2. 2 times 7, 14. Subtract to get our remainder. So 14 from 18 gives us 4. Okay, so now we're going to go into our decimals. And we've got, we've got to remember to bring down our 0 here. So we've got 40 divided by 7. So 40 divided by 7, well, 7 times 5 is 35. So 5 is going to be our next figure here. 5 times 7, 35. Subtract 35 from 40 gives us 5. Okay. Now, a little trickier here, but we should know that 7 into 50, 7 squared is 49. So it's always a good idea to know your square numbers and to think about those as well as just chunking up. So 7 times 7 we know is 49, and 49 is so close to this, it's a nice little gift. So we put our 49 down here and 7 in our hundredths place. And subtract 49 from 50 gives us 1. Let's just extend that, gives us 1. Okay, so now we've got 10 as our problem. Very easy. 10 divided by 7, well, only one 7 will go in there. So 1 times 7, 7. Subtract here. Now we've got 3, and with the 0, 30. So 30 divided by 7. Well, again, 7 times table. 7 times 4 gives us 28. So 4 is the next thing to write down. 4 times 7, 28. Subtract 28 from 30 gives us 2. Now I'm going to stop there because we haven't found any recurring pattern here, and we don't know this goes on forever. There might be a recurring pattern that's larger than this, so we don't know that there's not a recurring pattern. But certainly we've gone into as much detail as we need to at this stage, because we can now say that 18 divided by 7 equals 2.5771 to 3 decimal places, 3 dp. Okay? Or we could say equals 2.57 to 3 significant figures. So we've completed all the problems. If you're not sure of any of the methods I used there, go back and review the video. But also, just to complete the video, to keep going really in practicing these skills, give yourself some problems, try different numbers. You might want to try 3 figures, but I think I would just continue with 1 digit and 2 digit, divide them one way and then divide them the other, and you should get some interesting and challenging problems for you to attempt.